Everyone, I'm 1A. Today's topic is estimation for the difference of paired data. It is different from difference between two independent groups, right? Let's see what the paired data, okay? What is the difference from the previous topic? Okay, paired data is data related to two variables that are not independent of each other. We talked about two independent groups, populations, X and Y. We get from sample from this population and get samples from this population and compare them. What is the difference between the mean of X bar and y bar. Okay. For example, in this case, the problem should not be treated as involving two independent groups. The question, how much the difference is between the commuting time and living time of office workers. Okay. Then they are two data, commuting time and living time for one person. This is the case of paired data. It seeks to find out the difference in commuting and the living times for a single individual rather than comparing the commuting times of one group with the living times of another group, right? In particular, typical example of paired data is the investigation of differences between and after a particular point in time or event that we call before and after data. In instance, it may involve examining whether there is a difference effect before and after taking medication. Data on diet effects can also be considered as before and after data, right? If considered the weight, then before diet program weight and after diet program. What is the difference for one person? Not compare two different independent groups, right? The structure of a population refers to the joint probability distribution of two random variables, x and y, xy. In this context, if d equal to x minus 1 difference, x and y, then the question regarding the difference between the two variables, x and y, pertains to the mean mu sub d, okay, subscript d, because now we have another random variable d of the random variable d. The sample is obtained as x1, y1, xn, y1, y2, xn, yn, n paired data. Okay, in this case, the sample consists of n paired data, but when expressed in terms of the differences of the pair, say d1, d2, dn, d1 equal to x1 minus y1, d2 equal to x2 minus y2, dn equal to xn minus yn, then it is a problem of interval estimation for mu d. Okay, you have now one sample, d1, d2, dn. So it becomes to be one population problem, right? Therefore, 1 minus alpha 100% confidence interval for mu d is as follows. D bar minus t alpha over 2 sd, now the data d, standard deviation of a difference divided by square root of n, minus plus, same thing, okay? So let's see this graph. We have x, y, two random variables. So we have joint probability distribution function fxy. That is population. We obtain sample x1, y1 up to xn, yn in many paired data. Now let's see di equal to xi minus yi, I from 1 to n, say the size of a sample is n, then the population becomes to this way, d, one population problem. So there is D, random variable D, and its probability distribution is f of D. And the resulting sample will be D1 equal to x1 minus y1, Dn equal to xn minus yn. This comes to here. You understand the paired data problem? Okay? Looks like two variables problem, but you have to know your data, or your purpose is two independent groups, compare two independent groups, or just you want to know the difference between two variables. So you have to see that kind of a thing. Let's see example. There is a set of sample from a paired data. Okay, from a paired data. You may ignore this result anyway. They are what, 8 paired data like this: before x, after y. Then it is paired data. The sample size is 8, but for independent two groups, I told you from population 1, the sample can be taken out and one many. From here, sample y1 up to yn too many. The sizes of sample may be different. Okay, n1, take a n1 many sample from population 1, and too many sample from population 2 may be different. Okay, there is a Python coding here. You can just refer this kind of a thing. So, and I don't like to explain the details of a program. There is a result here. Okay, t-value 2.67, 2.67. P-value is two-sided p-value. One-sided p-value is 0.015. So two-tailed p-value will be times 2 will be 0.032. Okay? Okay, I think you may understand it easily. So different case, it depends upon your purpose. What do you want? You want to compare two independent groups, or you want to compare a paired data case? Okay, thank you. Bye.